Alright, so you might be asking yourself, what does Django code look like? Well, in a traditional data-driven website, a web application waits for HTTP requests from the web browser or other client. And when a request is received, the application works out what is needed based on the URL and possibly information in post data or get data. Depending on what is required, it may then read or write information from a database or perform other tasks required to satisfy the request. The application will then return a response to the web browser, often dynamically, creating an HTML page for the browser to display by inserting the retrieved data into placeholders in an HTML template. Django web applications typically group the code that handles each of these steps into separate files. Okay, so URLs, this part right here. While it is possible to process requests from every URL via a single function, it is more maintainable to write a separate view function to handle each resource. A URL mapper is used to redirect HTTP requests to the appropriate view based on the request URL. The URL mapper can also match particular patterns of strings or digits that appear in a URL and pass these to a view function as data. So a view is a request handler function which receives HTTP requests and returns HTTP responses. Views access the data needed to satisfy requests via models and delegate the formatting of the response to templates. Models. Models are Python objects that define the structure of an application's data and provide mechanisms to manage, add, modify, delete, and query records in the database. Templates. A template is a text file defining the structure or layout of a file, such as an HTML page. With placeholders used to represent actual content, a view can dynamically create an HTML page using an HTML template. Populating it with data from a model, a template can be used to define the structure of any type of file. It doesn't have to be HTML. Note, Django refers to this organization as the Model View Template (MVT) architecture. The section below gives you an idea of what these main parts of a Django app look like. We'll go into more detail later on in the course once we've set up a development environment. So let's see here. sending the request to the right view, urls.py. So a URL mapper is typically stored in a file named urls.py. In the example below, the mapper URL patterns defines a list of mappings between routes, specific URL patterns, and corresponding view functions. If an HTTP request is received that has a URL matching a specified pattern, then the associated view function will be called and passed the request. So as we see here, the URL patterns object is a list of path and or repath functions. Python lists are defined using square brackets where items are separated by commas and may have an optional trailing comma. For example, item 1, comma, item 2, comma, item 3, comma. The first argument to both these methods is a route pattern that will be matched. The path method uses a single angle brackets to define parts of a URL that will be captured and passed through to the view function as named arguments. The repath function uses a flexible pattern matching approach known as regular expressions. We'll talk about this more in a later article. The second argument is another function that will be called when the pattern is matched. The notation views.book_detail indicates that the function is called book_detail and can be found in a module called views, i.e. inside the file named views.py. Handling the request, views.py. Views are the heart of the web application. Receiving HTTP. So views are the heart of the application. Receiving HTTP requests from web clients and returning HTTP responses. In between, they marshal the other resources of the framework to access databases, render templates, etc. The example below shows a minimal view function, index, which could have been called by our URL mapper in the previous section. Like all view functions, it receives an HTTP request object as a parameter, request, and returns an HTTP response object. In this case, we don't do anything with the request, and our response simply returns a hard-coded string. We'll show you a request that does something more interesting in a later section. Note, a little bit of Python. Python modules are libraries of functions stored in separate files that we might want to use in our code. Here we import just the HTTP response object from the Django.http module so that we can use it in our view from Django.http import HTTP response. There are other ways of importing some or all objects from a module. Functions are declared using the def keyword as shown above, with named parameters listed in brackets after the name of the function. The whole line ends in a colon. So note how the next lines are all indented. The indentation is important as it specifies the lines of code are inside that particular block. Mandatory indentation is a key feature of Python and is one reason that Python code is so easy to read. Views are usually stored in a file called views.py. Defining data models, model.py. Django web applications manage and query data through Python objects referred to as models. Models define the structure of stored data, including the field types and possibly also their maximum size, default values, selection list options, help text for documentation, label text for forms, etc. The definition of the model is independent of the underlying database. You can choose one of several as part of your project settings. Once you've chosen what database you want to use, you don't need to talk to it directly at all. You just write your model structure and other code, and Django handles all the dirty work for communicating with the database for you. The code snippet below shows a very simple Django model for a team object. The team class is derived from the Django class models.model. It defines the team name and team level as character fields and specifies a maximum number of characters to be stored for each record. The team level can be one of several values, so we define it as a choice field and provide a mapping between choices to be displayed and data to be stored, along with a default value. A note, a little bit of Python. Python supports object-oriented programming, a style of programming where we organize our code into objects, which include different data functions for operating on that data. Objects can also inherit, extend, derive from other objects, following common behavior between related objects to be shared. In Python, we use the keyword class to define the blueprint for an object. We can create multiple specific instances of the type of object based on the model in the class. So for example, here we have a team class which derives from the model class. This means it is a model and will contain all the methods of a model, but we can also give it specialized features of its own too. In our model, we define the fields our database will need to store our data. Giving them specific names, Django uses these definitions, including the field names, to create the underlying databases. Querying data, views.py. So the Django model provides a simple query API for searching the database. This can match against a number of fields at a time using different criteria. For example, exact, case sensitive, greater than, etc. And can support complex statements. For example, you can specify a search on U11 teams that have a team name that starts with FR or ends with AL. The code snippet shows a view function resource handler for displaying all of our U09 teams. The line in bold shows how we can use the Model Query API to filter for all records where the team level field has exactly the same U09. Note how this criteria is passed to the filter function as an argument with the field name and match type separated by _ team level exact. So this function uses the render function to create the HTTP response that is sent back to the browser. This function is a shortcut. It creates an HTML file by combining a specified HTML template and some data to insert in the template provided in the variable named context. In the next section, we show how the template has the data inserted in it, to create the HTML. So here we go, rendering data, HTML templates. Template systems allow you to specify the structure of an output document using placeholders for data that will be filled in when a page is generated. Templates are often used to create HTML, but can also create other types of document. Django supports both its native templating system and another popular Python library called Jinja 2. Out of the box, it can also be made to support other systems if needed. The code snippet shows what the HTML template called by the render. I'll read that again. The code snippet shows what the HTML template called by the render function in the previous section might look like. This template has been written under the assumption that it will have access to a list variable called youngest teams when it is rendered, contained in the context that first checks if Alright, I'm going to read this paragraph right here over. Sorry about that. So let's see. The code snippet shows what the HTML template called by the render function in the previous section might look like. This template has been written under the assumption that it will have access to a list variable called youngest teams when it is rendered, contained in the context variable inside the render function above. Inside the HTML skeleton, we have an expression that first checks if the youngest teams variable exists, and then iterates it in a for loop. On each iteration, the template displays each team's team name value in an li element. Alright, so I will see you next in what else can you do with Django. Oops.